All right. Good evening, guys. How are you? Okay. It's say TK say Taku. Okay. Yesterday we had a problem. It was raining this side, so I couldn't coordinate my lesson. But I introduced probability, and I remember we had gone for some time for about 27 or so minutes while I was teaching. So today I'm going to start looking at the probability rules so that we can continue and be fast with our lesson. Okay, so probability.
So you are cutting.
I'm cutting. Hi guys, am I audible enough?
Yes, sir.
Can you hear me?
Yes, sir.
Can you hear me?
Yes, sir, we can hear you.
All right, thank you. So it means the person who said maybe I'm cutting, maybe your network is the one that has problems. Okay, so probability rules. We said number one, we have the general rule. Allow me to change marker. My black marker is now finished. We have the general rule. The general rule which says the probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B. Okay, that is the general rule which can be changed. So here, guys, you can use this one to calculate any of 1, 2, 3, 4. For example, if you want to calculate probability of A, it means you are going to make probability of A subject of what? Formula. For example, you have this, you have that, and you have that. You want this. So it means it's going to be probability of A or B minus probability of B, if you take this one across, plus probability of A and B, then you get probability of A. So it depends what you are given. If you are given this, that, and you want to calculate this, then you can calculate it. If you are given this, that, and you want to calculate this, then you can calculate it as well. If you are given this, that, and you want this one, it's obvious you can calculate it. So you use the general rule in so many instances. We shall see as we are doing our calculations. But for mutually exclusive events, for mutually exclusive events, remember we said mutually exclusive events are events that do not have common outcomes. So it means the intersection is 0. Therefore, the probability of the intersection is equals to what? 0. Hence, the general rule, if they say the events are mutually exclusive, then it means the general rule is probability of A or B is just equals to probability of A plus probability of B, like that, because we no longer have this one for mutually exclusive events. So that is another part of the general rule on part of the mutually exclusive events. Okay, so another rule, let's go to number 2. The second rule that we have is for exhaustive events. Exhaustive events, right? We talk about events A and event B are exhaustive if they take all elements from the sample space. For example, e.g., let's go back. If A is equals to 1, 3, 5. Then B is equals to 2, 4, 6. These are numbers on a what? On a dice. So if on a die, so you can see that A and B, they take all the elements from the symbol space because our symbol space is 1, 2, 3, 4, 5, 6. So we say A and B are exhaustive. Therefore, for exhaustive events, probability of A or B is equals to 1. Okay? The probability of A or B is equals to 1. So, on the statement, on a question, if they talk about exhaustive events and say A and B are exhaustive events, just know that their union, the probability is equals to what? 1. Okay? So, this is very, very important. For exhaustive events, if A and B are exhaustive, then probability A or B is equals to 1. Okay? Then number 3. Allow me to wrap this one. Number 3. We have complementary events. Number 3. We have complementary events. Right? There are 2 conditions for complementary events. The first one, number 1, complementary events are mutually exclusive. Meaning to say, they do not have any common elements and they also don't have any intersection. Okay? And 2, complementary events, they have to be exhaustive. They are also exhaustive. Right? So what does it mean? So it means for complementary events, if A and B are complementary events, then probability of A and B is equals to 0. And also the probability of A or B is equals to 1. Probability of A and B is equals to 0 because complementary events are mutually exclusive. And also probability of A or B is equals to what? To 1. Okay? So what does it mean? It means the probability of A plus the probability of B is equals to 1. Okay? Hence, this is simple. When you're talking about complementary events, we are talking about now, for example, if we are calculating probability not B, this is simply going to be 1 minus the probability of B. Okay? So probability not B, it means you are calculating what? Probability of A there. But probability of not B, it's 1 minus that one. This one can be written in another way. Probability B complement like that is equals to 1 minus the probability of what? Probability of B. So this is very important for complementary events. Okay? Then another rule that we have is rule number 4. Independent events. Independent events. And 2 events are independent. Two events are independent if the probability of one is not influenced by whether the other happens or not. By whether the other happens or not. Okay? And to check whether two events are independent, probability of A and B should be equals to probability of A times the probability of B. If this is equals to this, then A and B are independent. If it happens that probability of A and B is not equals to, let's say you have calculated this one, you got it, then you multiply probability of A times probability of B, then you get a different answer. Then if they are not equal, then A and B are not independent. We don't say they are dependent. We say they are not independent. Okay? So these are independent events. These are independent events. That is how we get independent. So we use this one for independent events. This is very, very important. In the interpretation, A and B are independent if this one and this one are equal. Then if the intersection is not equal to the product of their probabilities, then A and B are not independent. Okay? That is very, very important. Okay? So these are the rules that we have in probability. Okay? So now for the probability presentation, we have Venn diagrams. We have tree diagrams. We have contingency tables. So if I try to teach these ones one by one now, we're going to have a problem. So I selected the questions that I selected there. You see that they actually you have Venn diagrams, tree diagrams, and also contingency tables. So we're going to use those ones as a revision for Venn diagrams, tree diagrams, and contingency tables. Okay? Right? So guys, if you check on the worksheet that I sent, there is one that is written number 1. I wrote it number 1. I took it today, right? Which is exercise number 1. So before we go to the past exam question, I want us to just quickly go through that because it can help somebody. So let's go there. Right, it's exercise number 1. So we have, let's start with A, which is saying two events A and B are such that probability of A is equals to 0.6, the probability of B is equals to 0.5, and probability of A and B is equals to 0.3. Calculate, determine the probability of A or B. Right? That is simple. Which rule are we going to use, if you remember, in order to calculate probability of A or B? Which rule are we going to use? We numbered them 1, 2, 3, 4.
Use the general rule.
We're going to use the general rule because the probability of A or B is equals to the probability of A plus the probability of B minus the probability of what? A and B, which is simple. 0.6 plus 0.5 minus 0.3. What do we get? Zero 0.6 plus 0.5 minus 0.3. We get 0.8. So it means the probability of A or B is equals to 0.8. Okay? Let's move on and go to the next. Right? Let's check the next one. The next one is saying two events X and Y are such that probability of x is equals to 0,4, probability of y is equals to 0,3, probability of x or y is equals to 0,6. Determine probability of x and y. Okay? Determine probability of x and y. Right? So if we check from there, again, we're going to use what? The general rule. The general rule is going to be probability of x or y is equals to the probability of x plus the probability of y minus the probability of what? X and y. This one we have it, that is 0.6. This one, 0.4 plus 0.3 minus probability of x and y. That is the unknown. Okay? So since it's a negative, we can take it across, then this 6 we take it across as well. So it means probability of x and y is equals to 0,4 plus 0,3 minus 0,6. So from there, we can see that is going to be 0.7 minus 0.6, which is going to be 0,1. So we see that this one is what? It's simple from the general rule. Okay? There's one that I saw that has mutually exclusive events there. Okay? I want us to look at them. Right? That is, let's go to number E. Number E is saying two mutually exclusive events. Now they said mutually what? Exclusive events, right? Are such that probability of A is equal to 0.3 and probability of B is 0.4. Probability of B is equal to 0.4. So what is probability of A and B in this case? They say that these are mutually exclusive events. So what is the probability of A and B? I'm asking you guys, what is probability of A and B?
0,
Remember that this is going to be what? 0. Altogether. So it means the general rule here is going to be probability of A or B is equals to probability of A plus probability of what? B only, which is just 0.3 plus 0.4, which gives us 0.7. Okay? So because remember that this one is 0 because of mutually exclusive events. All right. Now let's move on. Let's check another one. The last one here that I want us to check is number H. Number H is saying two exhaustive events. What is the keyword here? Exhaustive events. Right? M and N are such that the probability of M is equals to 0.7, the probability of N is equals to 0.5. Determine probability of M and N. Okay? So now we're gonna use the addition, the general rule. Probability of M or N is equals to probability of M plus probability of N minus probability of M and N. Okay? But what is the probability of M or N? Because we are only given probability of M and also probability of N. The key word is these are exhaustive events. So what is probability of M or N? It's what? It's 1. Because they are exhaustive what? Events. Okay? So 1 is equals to 0.7 plus 0.5 minus probability of m and n. Bring this one that side, probability of m and n is equals to 0.7 plus 0.7 plus that one is going to be 1 point what? 1.2 minus 1, okay, which is going to give us 0.2. That is the probability there. All right. So I think here I have touched exhaustive. I've touched the other part. Okay. So the last one, the X and Y are two exhaustive events such that blah, 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 blah. Let's leave it. Let's go to the other one. The other exercise that is written exercise number 2. Let's go to exercise number 2. Okay. On exercise number 2, we have number B. Let's do number B. Given two independent events, A and B. Here, the key word is we are given that they are independent events. Right? That is a key word. They are independent events such that the probability of A is equal to 0.6 and the probability of B is equal to 0.5. Now determine probability of A and B. What is the keyword here? These are independent events. So probability of A and B is equal to probability of A times probability of what? B. Right? Because these are what? Independent events. Hence, probability of A and B is equal to 0.6 times 0.5. 0.6 times 0.5 gives us 0.3. 0.6 times 0.5 gives us 0.3. So it means the probability of A and B is equal to 0.3 because these are independent events. So as you are answering, check what they are asking about. Okay? Or the keywords that are there. Now, probability of A or B now becomes simple. Probability of A or B is going to be equal to probability of A plus probability of B minus probability of A and B, which is just 0.6 plus 0.5 minus 0.3, which is going to be 1.1 minus 0.3, which is going to be 0.8. Simple. So the keyword, we are told that they are independent. And for independent events, what do we know? Probability of A and B is equal to probability of A times probability of what? B. Okay? All right. Let's look at one last one there of proving independence. Right? No, we no longer have any question there that proves independence. All right, we have it. Number D. Right? Determine with full motivation. Number D. Determine with full motivation whether or not the events of X and Y are independent in each of the following cases. Right? The first one, its probability of X is equal to 0.8. Probability of Y is equal to 0.5. Then probability of X and Y is equal to 0.6. Right. So in order to prove whether they are independent or not, what am I supposed to do? Multiply that one and that one. Probability of X times the probability of Y is equal to 0.8 times 0.5, which is equals to 0.8 times 0.5, which is equals to 0.4. So from there, now you compare this one to that one. Are they the same? No, they are not the same. Then your conclusion is going to say probability of X and Y. Is it equal to that? No. So you indicate is not equals to probability of X and the probability of Y. Therefore, if they are not equal, it means they are not independent. If they are not equal, this one and that one, it means they are not independent. Okay? Right? Let's check the next one. The next one, number 2 on D, still on D. It says the probability of X is equals to 0.2, probability of Y is equals to 0.3, probability of X or Y is equals to 0.44. So they want us to check if they are independent or not. Okay, so here we have to calculate firstly probability of X and Y. How do we calculate it? Now we have to use our general rule. Probability of X or Y is equals to probability of X plus probability of Y minus probability of X and Y. Okay, so this is going to be 0.44 is equals to 0.2 plus 0.3 minus probability of X and Y. So probability of X and Y is equals to 0.5 minus 0.44, which is equals to 0.5 minus 0.44, which is 0.06. Okay, so that is the probability of X and Y. Then the probability of X times the probability of Y is equals to 0.2 times 0.3. Okay, 0.2 times 0.3, we get 0.06. Okay, we get 0.06. Comparing that and that, we see that they are equal. So our conclusion says, let me conclude in green there. Our conclusion says probability of X and Y is equal. We are now comparing these numbers. Is equals to probability of X times probability of Y. So since they are equal, it means X and Y are independent because they are equal. They are independent. Okay? Right? So that is that with the rules of probability. Now I want to move on to the Venn diagram. Okay? Any questions, guys? Oh, silence means confusion, or silence means we are covered. Okay? Right? Now, let's move on to question number 10. The one that is talking about Instagram and the like. Okay? I didn't number them, sorry. But it's question 10, the one that is talking about a survey. Okay? Right? I'll read. Question 10. Right? It says, a survey was conducted amongst 100 learners. So it means the sample space is equals to 100 learners. 100 get 12 learners about their use of Instagram, their use of Twitter, their use of WhatsApp on their cell phone. The survey revealed the following: 8 use O3, 12 use Instagram and Twitter, 5 use Twitter and WhatsApp but not Instagram, X use Instagram and WhatsApp but not Twitter, 61 use Instagram, 19 use Twitter, 73 use WhatsApp, 14 use none of these applications. Draw a Venn diagram to illustrate the above information. So I guess this is not your first time to see a Venn diagram. A Venn diagram, it has a rectangle, which is the sample space. Okay? If it was in probability, sample would be 100. I mean 1, because it would be 100 over 100. So it would be 1. So here we are having 3 events. And the events are going to be represented by interlocking circles. So the circles you have to interlock. Okay? So I'm going to draw my circles. Right? First one. Second one. Then another one. Okay? So these circles are representing different events. So the other event is going to be Instagram. This is going to be Twitter. That is going to be WhatsApp. Okay? Right, now let's populate our events. Right? Let's go back where they are talking about 8 use O3. So it means this is the intersection of all the 3. Where do we get the intersection of all the 3? It is somewhere here. Okay, let me draw this circle so that it's a bit bigger. Okay, right? So the intersection of all the 3 is here. That is where we have what? 8. We are using all the 3. So if you see, this 8 is found in Instagram, it's found in Twitter, it's found in what? In WhatsApp. So 8 use all the 3. Okay? So 12 use Instagram and WhatsApp. 12 use Instagram and Twitter. So if you're talking about Instagram and Twitter, we are talking about that. That is Instagram and Twitter. Here, this is Instagram and Twitter only. Okay? So this part is Instagram and Twitter. So there are 12, but already we have 8. So how many use Instagram and Twitter only? Or how many use Instagram and Twitter but not WhatsApp? There are how many? I heard somebody say. You were correct. 4. Such that 4 plus 8 gives us what? 12. Okay? So now the next one says 5 use Twitter and WhatsApp but not Instagram. So which ones are they? Twitter and WhatsApp but not Instagram. So it means this one we don't have a hassle. We just write them like that. Ne? So how many use Twitter and WhatsApp? There are 5 plus 8, which is 13. But remember that they said 5 Twitter and WhatsApp, but not Instagram. So it means we just write here. Okay? Then the other one says X use Instagram and WhatsApp, but not Twitter. So it means here we have what? X. Okay? Then 61 use Instagram. So we want to find those ones who are using Instagram only and nothing else. Right? What do we do now? Remember they said 61 the whole circle here should have what? 61. But already the circle is having 4, 8, and x. So in order to get this one, we are going to say 61 minus 4 minus 8 minus x. What do we get? 61 minus 4 minus 8?
49 minus x.
Yes, it's going to be 49 minus x. Okay, right? Then the next one says 19 use Twitter. 19 use Twitter. So it means the whole circle for Twitter should have what? 19. Right? So in order to get Twitter only, we say 19 minus 4 minus 8 minus 5. What is already there in the circle for Twitter? What do we get? 19 minus 4 minus 8 minus 5?
2.
We get 2. 19 minus 4 minus 8 minus 5. We get 2. Okay. Then they say 73 use WhatsApp. So in order to get WhatsApp only, we are going to say 73 minus 8 minus 5 minus x. What do we get? 73 minus 8 minus 5. What do we get?
X.
We get 60 minus x. Then 14 use none of these. So 14 is outside of these events. You see? So if you add everything, you should be able to get what? 100. Are we together? Right. Now we have drawn the Venn diagram. Now the question says 10.1. We are now going to use the Venn diagram to answer. Calculate the value of x. Now, in order to calculate the value of x, we add everything that is in the box. It should give us what? 100. So that is going to be 10.2. That is going to be 49 minus x plus x plus 8 plus 4 plus 60 minus x plus 5 plus 2 plus 14 should give us what? The sample space, which is 100. They should give us 100 learners. Okay, so let's calculate 49 plus 8 plus 4 plus 60 plus 5 plus 2 plus 14, we get 142. Negative x plus x is gone, so we are left what? This one, they cancel because it's negative x plus x, they are gone. So we are left with 142, and we are left with what? Minus x is equals to 100. So we take 100, we take x that side, so we have 142 minus 100 is equals to x. So x is equals to 42. X is equals to 42. Immediately after calculating 42, now we know that 49 minus 42 gives us 7. So you go and write your 7 here. Right? Then 60, this one now, it's what? It's 42. But you don't have to change on the original. I'm now just changing it because I want to use it. Ne? We are going to use it. 60 minus 42 is equals to 18. Okay? So here it's still x, but we know that it's 42. Okay? Right? Now, let's go to the next one. We are now using the Venn diagram to answer questions. So I'm going to add some more questions that comes out of my mind that is not on the question paper, so that at least we learn more. Okay? So let's first finish the questions that are there, which are saying calculate the probability that a learner chosen in random uses only one of these applications. Only one of this application. Probability only one. How many are using only one? Here we have how many? 7. Here we have how many? 2. Here we have 18. So there are 7 plus 2 plus 18 over the total, which is 100. What do we get? 27 over 100. Only one. Guys, these ones use how many? These 4 use how many? Oh, am I speaking alone? These 4 use how many?
Through Twitter and Instagram.
Yes, Twitter and Instagram. These 8 use how many?
All 3.
All 3. These ones, X use how many? 2. These ones are using 2. X, they are using 2. It's only Instagram and WhatsApp. Right? Let's move on to the next. The probability, calculate the probability that a learner, calculate probability that a randomly chosen learner use at least, sorry, at least 2. What does at least mean? At least means 2 and above. Are we together? At least means what? 2 and above. So probability at least 2 is equals to, so these ones 42, they use 2, plus 4, they use 2, plus 5, they use 2, plus 8, they use 3, over 100. Are we together? Because this is at least 2, so it means 2 and above. So which is going to give us 42 plus 4 plus 5 plus 8, 59 over 100. That's the probability. Okay? So at least 2 means 2 and above. These ones use 2, these ones use 2, these ones use 2 and above. Okay? Right? Then another one would say, another one that comes from my mind says, calculate the probability a randomly chosen learner use at most 1. Right? At most 1 means 1 and below. Okay? Means 1 and below. So probability at most 1 is equals to, right, how many are using 1? We have 7 plus 18 plus 2. And remember, at most it's 1 and less. So you have to include what? The 14. We are using 0 over the sample space, which is 100. So that is going to be 7 plus 18 plus 2 plus 14. That is 41 over 100. That is at most 1. So that is how we use a Venn diagram. That is how we use a Venn diagram. So remember, they can be numbers like this, or they can be probabilities. They can be probabilities. Let me check our time. We are going to look at another one that is probabilities. But for now, let's go to the tree diagram. Okay? So that is the Venn diagram. Right. Now, let's go to the next, which is question number, is it here? All right, question number 10, the one that is a table. The one that is a table. 10.1. A bag contains 7 yellow, 3 red balls, and 2 blue balls. A ball is chosen at random from the bag and not replaced. A second ball is then chosen. Determine the probability that of the 2 balls chosen, one is red and the other one is what? Blue. Of the 2 balls chosen, one is red and the other one is what? Is blue. So this one requires that you use a tree diagram. Tree diagrams is used when you're representing 2 or more experiments. If you're using 2 or more experiments, you use what? The probability tree diagram. So the first experiment, a ball was chosen from the bag. The bag is having how many balls? It is having 7 plus 3, 10, 12 balls. So this one is going to be yellow, this one is going to be red, and this one is going to be what? Blue. What are the probabilities? 7 over 12, 3 over 12, and 2 over 12. Okay? So the second experiment now is choosing again. Right? It's either you still can choose yellow, red, blue, yellow, red, blue, yellow, red, blue. But there's a condition that if a ball was chosen, it's not replaced. You should be careful there. If they replace the ball, it means the balls are going to remain 12. If they take them out, it means that the balls are no longer what? If it's not replaced, they are no longer 12, but they are now what? They are now 11. Right? So if this branch here represent yellow balls, that the first experiment, a yellow ball was what? Picked out. So it means we are no longer having 7 yellow balls. How many are we having? We are now having what? 6 yellow balls out of 11. Okay? But on that branch, red is not affected. So we are still having 3 out of 11. And blue is not affected. We are still having 2 out of 11. Okay? Then we go to this branch. Right? Now a red ball was picked on the first experiment. It means the yellow ball was not affected. There are still 7 out of 11. But a red ball was picked here and there were 3. Now a red ball is affected. Now we are now having what? 2 out of 11 because the red ball was taken out there. Then a blue ball was not affected. It's still 2 out of 11. Okay? Then down there, yellow was not affected when we picked blue, so it means there are still 7 out of 11. Then red is not affected here on this branch, first branch, so it means we have 3 out of 11. Then blue is affected because it was taken the first time. Then we have 1 out of 11. Remember that a ball was picked and it was not replaced. Okay? So what are our outcomes? Our outcomes are yellow. Let me write it in another color. Our outcomes are yellow, 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 red, yellow, blue, red, yellow, red, 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 blue, blue, yellow, blue, red, blue, blue. So how do we get this one? It's 7 over 12 times 6 over 11. So you go multiplying to get yellow, yellow. It's 7 over 12 times 6 over 11. Then the other one is going to be 7 over 12 times 3 over 11. Then 7 over 12 times 2 over 11, going on like that. Okay? So here in this question, it's asking, what is the probability that of the two balls chosen, one is red and the other one is blue? One is red and the other one is what? Blue. So where do we have red and blue? We have it here. The one is red, then the other one is what? Is blue. Then we also have here. Okay? So probability red and blue. The other one is red and blue. Is probability RB plus probability blue, red. Okay? So what is red and blue there? That is going to be 3 over 12 times 2 over 11 plus the other one 2 over 12 times 3 over 11. So you take your calculator there, then you calculate. So 3 over 12 times 2 over 11 plus 2 over 12 times 3 over 11. So the answer is going to be 1 over 11. Answer is going to be 1 over 11. So that is how we use a probability tree diagram. That is the probability tree diagram. Okay? Right? Any questions on this one? So be careful. They can say with replacement or without replacement. So here it was picked up without replacement. Okay? Now, let's move from there. Let's go to the other one. Right? Still on that question, I want us to do 10.2, which is a contingents table. Right? A contingents table, our contingents table is having sandwich, pasta, then fruit, juice, bottled water, like that. Okay? Then here we have total, and also there we have total. Right? Then we are having A, we are having 30, we are having B, 250, then that is 200. Right? So now it's saying the probability of a learner choosing fruit juice and sandwich. Fruit juice and sandwich is that one. That is fruit juice and sandwich, where they meet. Sandwich, fruit juice. Sandwich, fruit juice. So where they meet, that is their intersection. Okay? Where they meet is that is the intersection. So the probability of fruit juice and sandwich is equals to 0.48. Right? 10.2.1. Calculate the number of learners who chose fruit juice and sandwich. Okay? So how do we get that? That is A over 250 is equals to 0.48. A over 250, A over 250 is equals to 0.48, because A is the number of learners want sandwich and fruit juice. So over this one, we are told the probability is 4.8. Okay, so that is simple. A is equals to 0.48 times 250. Then what do we get? 0.48
120.
times, you get 120. Okay, so it means A there is 120. Okay, so that is simple. 120 plus 30, what do we get, Kabi? We get what?
150.
150. And 200 and 250, what do we get here? We get 50. What do we get here? Because 30 plus here, we should get 50. What do we get?
20.
We get 20. 200 minus 120, what do we get?
80.
80. Then 80 plus 20?
100.
100. Okay, so we have populated the stuff. Okay, now the question goes on to ask and say, (10.2.2) is the choice of a fruit juice independent of the choice of a sandwich for lunch on a day? Show all your calculations. Now they're talking about independency, the one that we once talked about. And we know that probability of fruit juice and sandwich, we are given 0.48. Right? So now we want probability of fruit juice times probability of sandwich to check if they are independent. Okay? What is the probability of fruit juice? The probability of fruit juice, what is the total for fruit juice? It's 150. So probability of fruit juice is 150 over 250 times, what is the probability of sandwich? There we have sandwich. The total for sandwich is what? 200 over 250. Probability of fruit juice, the total for fruit juice is 150 over 250. The total for sandwich is 200 over 250. So if we multiply the two, what do we get? 150 over 250 times 200 over 250. We see that we get 0.48. Right? We get 0.48. If you got a fraction, change it to decimal so that you can compare. So now we compare this one and this one. What do we see? We see that they are the same. So our conclusion is going to say probability of F and S is equals to probability of F times probability of S. They are equal because of that. Therefore, fruit juice and sandwich are independent. Therefore, I'll just write independent. Therefore, fruit juice and sandwich are independent. Okay, so that is how you calculate using a conjugates table. That is the conjugates table. Okay, so guys, I have tried to cover as much ground as possible. And I think with this video, with the last video, for those ones who would say probability I didn't understand it totally, if I send the video that we did yesterday for the 27 minutes and also this one, I think it's going to actually help you on issues to do with probability. So the next time we meet, I think we can do fundamental counting principles. Then we'll be done with the probability part, because it comes in two. It has probability and fundamental counting principles. So just for interest sake, let's do another number 10 there, that is having a Venn diagram. Then we call it a day. Okay? Right? So the other number 10, it was having a Venn diagram that is already drawn. Right? Which is saying A, B, and C are events. I'm going to draw the Venn diagram. Then we are having circle there, another circle, and another circle. That is B, that is C, that is A. Then we have Y outside there. Then in there, we have X in between. We have 0.1, 0.183, 0.05, 0.2, 0.15, 0.05. Okay? If it is given that the probability that at least one of this event, at least it means one and more. So it means the probability at least one of these events will occur. So probability at least one is equals to 0.893. If it is given that, then calculate y, right? Calculate the value of y. So at least one, we are talking about everything here. That is at least what? One. This one. That is at least what? One. Okay? So that is simple. How do we get it? Now to get y. If we add this one plus y, we should get the sample space here is 1, because they are talking about probabilities. Probabilities, if you add them all together, they should give you what? 1. So it means 0.893 plus y should give us what? 1. Therefore, y is equals to 1 minus 0.893. See what we get? 1 minus 0.893. We get 0.107. That is what we get. So it means y is equals to 0.107. Okay? Then, now, they say x, the probability that all three will occur. So number B, that was number A. Then number B should be simple. Remember that if we add everything here, we get 0.893. So that is simple. 0.05 plus 0.1 plus 0.183 plus 0.2 plus 0.05 plus 0.15 plus x should give us 0.893. So if we add these probabilities, what we get? 0.05 plus 0.1 plus 0.183 plus 0.2 plus 0.05 again plus 0.15. We get 0.733 plus x is equals to 0.893. So it means x is equals to 0.893 minus 0.733. So minus 0. Then we get that x there is going to be 0.116. Otherwise, if you are not given this one, you're going to add that plus that. Then you equate it to what? To 1. Then you calculate x. Okay? So in this case, x is 0.13. So y is equals to 0.107. X is equals to 0.16. Okay? right? Then now we use that one to answer. Remember that these are probabilities. These are not numbers. These are now probabilities. And the total probability, the symbol is 1. Determine the probability that at least 2 of these events will take place. At least 2, that is 10.1.2, right? Right? That is that. 10.1.2 probability at least 2. So it means 2 or more, right? So what is 2 or more? We are here, 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 and here. So that is going to be equals to 0.1 plus the probability at least 2. It's going to be 0.1 plus 0.15 plus 0.2 plus 0.16, which is x. What do we get? 0.1 plus 0.15 plus 0.2 plus 0.16. Then you get 0.61. That is at least 2. At least 2 means 2 or more. So here 2, that is A and B. 2, that is C and B. 2, that is A and C. 3, that is A, B, and C. Okay? Then the last one. Are events B and C independent? 10.1.3. B and C, are they independent? Which one is B and C? B and C is that one. Okay? So probability of B and C is going to be 0.16 plus 0.2. What do we get? 0.16 plus 0.2. 0.16 plus 0.2. You get 0.36. Okay? Then what is the probability of B? The probability of B is going to be 0.1, all that is in B, plus 0.183 plus 0.16, which is x there, plus 0.2. That is the probability of B. 0.1 plus 0.183 plus 0.16 plus 0.2. Then the probability of B is equals to 0.643. What is the probability of C? Everything that is in C, 0.05 plus 0.2 plus 0.16 plus 0.15. That is going to be 0.05 plus 0.2 plus 0.16 plus 0 plus 0.15. We get 0.56. Okay? So now to check independence, we have to multiply the two. Probability of B times probability of C is equals to 0.643 times 0.56. What do we get? 0.643 times 0.56. We get 0.36, rounded off to 2 decimal places. So you check this one and that one. What do you see? They are the same. Therefore, probability of B and C is equals to probability of B times probability of C. Therefore, they are independent. Okay? Guys, any questions? Silence means there are no questions. So, guys, the next time we meet, we have to talk about the fundamental counting principles, which is also part of probability. That is why I left that other part, 10.2, which is talking about 4 digits numbers. It's fundamental counting principles. We have our permutation and combinations there, and we use the factorials and stuff. So we are going to talk about that the next time we meet. Okay, so have a wonderful day and enjoy your holiday. Tomorrow is also a holiday, a workers' day. So enjoy yourselves, guys. I'm going to send the videos so that you can also check. Otherwise, enjoy your day. Don't forget to comment with any word that you got from the lesson, so that say Desmond can see your attendance. Thank you very much.